There is a machine in Boulder, Colorado, that can tell you how high it is off the ground, without looking at the ground. It doesn't use a laser, it doesn't use pressure or radar or a map. It works out its own altitude by measuring one thing only: how fast time is passing where it sits. Lift that machine by the width of a pencil tip, and time speeds up, measurably, repeatably, which leads to a sentence that sounds like nonsense and is simply true. Right now, your head is aging faster than your feet. Not as a metaphor, not it feels that way. Your skull and your shoes are moving through time at genuinely different rates, and the gap between them has been measured in a laboratory over a distance of 33 centimeters, about one step on a staircase. The effect is absurdly small. Over an entire 80-year life, standing upright, your head gains something on the order of 90 billionths of a second on your feet. You will never notice it. Nobody has ever noticed it. But too small to notice and not real are very different things, and the difference between them is the whole of modern physics. Because if that is true, then something we all quietly assume about the universe is false. We assume that time is the one thing everybody shares, that whatever else is different about you and me, where we are, how fast we're going, at least the clock is the same clock. It isn't. There is no universal clock. There never was. And to understand why your head is winning this race, you have to give up the idea you were taught about what gravity actually is. Here is the thought that started it. In 1907, Einstein imagined a man falling off a roof and realized that while he falls, that man feels no gravity at all. He's weightless. If he let go of a hammer, it would hang beside him, perfectly still. Falling and floating are the same experience, which means gravity can't be a force that grabs you and pulls. If it were, you'd feel it doing that. So Einstein proposed something stranger. Gravity is not a pull, it is a shape. Mass bends the four-dimensional fabric that space and time are made of, and everything that moves, including light, including you, simply follows the contours of that fabric. You aren't being dragged toward the earth. You're rolling down a curve you can't see, and here's the part that matters for your head and your feet. The fabric that bends isn't just space, it's space and time together. One thing. Bend it, and you don't only bend distances, you bend duration. The deeper you sit in that curve, the closer you are to the mass, the slower your clock runs compared to a clock further out. Not because your clock is faulty, because time itself is running slower there for everything. Your watch, your heartbeat, the decay of the atoms in your bones. Your feet are 1 meter deeper in the Earth's curve than your head. So they are, very slightly, living in the past. Physics doesn't get to keep a beautiful idea just because it's beautiful. So, proof. 1959, Harvard University. Two physicists, Pound and Rebku, fire gamma rays down a lift shaft in a tower, 22.5 meters, top to bottom. If Einstein is right, the radiation should arrive at the bottom with its rhythm shifted because the bottom of the tower runs on slower time. It does. The measurement matches the prediction to within a few percent. The first time anyone caught gravity bending time inside a single building. 1971. Two scientists, Ha-Fei Liu and Qi Ting, buy plane tickets for themselves and for 4 cesium atomic clocks. They fly around the world eastward, then westward, then compare their clocks to the ones that stayed home at the US Naval Observatory. The traveling clocks come back disagreeing with the ones on the ground by hundreds of billionths of a second, in the direction predicted by the amount predicted. Time travel, in the only sense that's real. They came home very slightly out of step with everyone else. 2010, Boulder, Colorado. Now the clocks are good enough to stop needing planes and towers. A team at the National Institute of Standards and Technology compares 2 aluminium optical clocks and simply raises one of them by 33 centimeters. The raised clock runs fast. That's it. That's the experiment. 1 foot of altitude, and the universe hands you a different rate of time. The Institute's own headline for the result was, "Your head is older than your feet, 2022. They stopped moving the clock at all. A jeweler, A team led by Junye traps about 100,000 ultra-cold strontium atoms in a column of laser light 1 millimeter tall, the thickness of a credit card, and measures the top of that column against the bottom. Different time, across 1 millimeter, inside a single cloud of atoms. That is where we are now. Time isn't just different between planets or between spaceships. It's different across the width of a pencil line, and we can watch it happen. At this point, you might reasonably ask, fascinating, but does any of it do anything? You used it this week. Every satellite navigation system on Earth is built on clocks in orbit. Those clocks sit higher in the Earth's gravity curve than you do, so they run fast, by about 45 millionths of a second a day. They're also moving at several kilometers a second, and motion slows a clock the other way, costing about 7 millionths of a second a day. Net result, a satellite clock gains roughly 38 millionths of a second every single day compared to yours. 38 millionths of a second sounds like nothing, but the system works by timing radio signals traveling at the speed of light, and in 38 microseconds, light covers about 11 kilometers, which means, without relativity built in, your phone's idea of where you are would drift by about 10 kilometers per day. So the engineers did something wonderfully blunt about it. Every navigation satellite is launched with its clock deliberately set wrong, tuned slightly slow on the ground, so that once it reaches orbit and time speeds up around it, it ticks correctly. We manufacture our clocks with Einstein's correction pre-installed, every one of them. Because the universe genuinely is like this, and the alternative is getting lost. Now take the effect and stretch it. Live your life on a mountain instead of at sea level, and you sit higher in the curve, so you age very slightly faster than someone on the coast. Over a lifetime, it amounts to fractions of a millisecond, a rounding error. But it is not zero, and that matters more than it sounds. Go the other way. The center of the Earth sits at the very bottom of our planet's gravity well, so its clock has been running slow since the day the planet formed, by about 3/10 billionths of a second a year. Except the Earth is 4.5 billion years old. Run that lag for the entire life of the planet, and it adds up. In 2016, physicists in Denmark did the arithmetic properly for the first time. Richard Feynman had guessed the gap was a day or two, and physics had quoted him for decades without checking. The real answer is about 2.5 years. The core of the Earth is 2.5 years younger than the ground you're standing on, and at the far end of the scale, the effect stops being a rounding error and becomes the whole story. Near an extremely dense object, a neutron star, a black hole, the curve gets so steep that a clock there crawls compared to ours. Close enough to the edge of a black hole, an hour for you would be years out here. Not a special effect. The same physics that separates your head from your feet, turned all the way up. So here is the big picture. There is no master clock. Nothing in the universe is keeping official time. Every object, every planet, every satellite, every person carries its own clock, running at its own rate, set by exactly where it sits in the curvature of space and time, which means the word now is smaller than we think. Your now is yours. It belongs to your position, your altitude, your speed. Two people who part, live differently, and meet again do not come back the same age, not by a meaningful amount, but not by nothing either. And we've got so good at measuring it that clocks are becoming instruments for reading the Earth itself. Put an optical clock somewhere, watch how fast time runs there, and you can infer the mass beneath it, magma rising under a volcano, water moving underground, the true shape of sea level. A field called relativistic geodesy, telling time so precisely that it turns into geology, which is the part I keep coming back to. Einstein wrote it down as pure thought a century ago, with no hope of ever seeing it. And now it's in the phone in your pocket, and in a machine in Colorado that can feel a millimeter. The universe was never obliged to be this strange. It just is. Thanks for watching The Big Picture. If you want to know how it all actually works, subscribe. There's a lot left to look at.